Okay, good morning and welcome to the third day of the conference. Our first speaker today is Yimei Xiang, who comes to us from Rutgers University. Yimei got her BA in Chinese linguistics at Peking University in 2010 and her PhD at Harvard in 2016. She was a college fellow at Harvard for the following year, and then moved to Rutgers University in 2018, where she has been since then. Her research interests broadly include semantics, philosophy of language, syntax-semantics interface, experimental approaches to semantics and pragmatics, and she focuses on Chinese and East Asian linguistics. Her current research program includes questions with complex structures, questions under attitudes, higher order readings, and mentioned some readings of questions, polarity items and free choice items, multifunctional words in East Asian languages, and compositionality and binding. She's published in Natural Language Semantics, Linguistics and Philosophy, and Journal of Semantics, has given talks at many major conferences, including SALT, the Amsterdam Colloquium, NELS, Zine Bedeutung, ILLC, as well as having many invited presentations at conferences, at universities, and colloquia. She's done reviews for every major journal in linguistics and for all major conferences as well. And we are very happy to have her here today to talk about relativized exhaustivity, mention some, and uniqueness. So you may.
Thank you. I will put the slides in the chat, and you can also download that from Slack. Okay, let me start screen sharing. Can people see the shared slides? Okay, thanks. Right, thanks very much for having me here. It's a great pleasure to have this opportunity to present my work to this audience. So this presentation, I will cover two issues related to question semantics, mention some readings, and uniqueness effects. So first, what is a mention some reading? In most cases, to answer a question, we need to specify all the true answers to that question. So for example, if someone asks Chris, who did you invite to give a talk here? And then who let you know all the 5 speakers, not just some of them. However, double questions with an existential goal-oriented model such as can be naturally addressed by mention some answers. So for example, in one, where can we get coffee? You can say Starbucks. So this is a mention some answer in a sense that this answer only specifies some of the true answers. So the existence of mention some answers argues that question interpretations are not always exhaustive. And can questions also accept mention all answers, which can be stated either as a conjunction as in 1B or as a disjunction as in 1C. What about uniqueness? Questions with a singular which phrase are subject to a uniqueness effect. So for example, in 2, which child came? Here, child is a singular noun. And this question implies that only one of the children came. To account for this uniqueness effect, Dayao 1996 argues that question interpretations must be exhaustive. A question is defined only if it has an exhaustive true answer. So here arises a dilemma. On the one hand, the existence of mention some reading argues that question interpretations are not always exhaustive. Well, to account for the uniqueness effects in questions with a singular adaptive phrase, we do want to say that question interpretations are exhaustive. So in this talk, to solve this dilemma, I will argue for a new question interpretation condition that is called relativized exhaustivity. So this talk will be divided into two parts. Part one is on the composition of Kant questions, and part two is to present a solution to the dilemma between uniqueness and dimension sum. This talk is based on a manuscript with same title that can be downloaded on Limbus with a lot of cuts and simplifications. So part one, composing Kant questions. Earlier approaches to dimension sum account for the licensing and distribution of dimension sum readings by pragmatic factors, such as the conversational goals of the questioner. So for example, in 3, where can we get coffee? If the goal is just to get a cup of coffee, then a dimension sum answer is sufficient. If the goal is to investigate the local coffee market, then a dimension all answer will be required. So this sounds pretty intuitive and straightforward. However, dimension sum answers to Kant questions are subject to a grammatic constraint that is called dimension 1 only. And this constraint cannot be explained by pragmatic factors, which I'm going to show next. So because of this, and analyze dimension sum as a grammatical phenomenon, and I'll argue that the primary origin of dimension sum is the presence of the existential modal verb can, which appears inside the question nucleus. So what is the dimension 1 only constraint? This constraint just says a dimension sum answer to a Kant question specifies only one option that resolves the question. So according to this constraint, dimension sum more precisely should be called dimension 1. To illustrate the dimension 1 constraint, let me show you the contrast between dimension 1 and dimension few in two cases. One is the embeddings of Kant questions, and the other is matrix Kant questions in discourse. Embeddings of Kant questions allow for dimension 1 and dimension all interpretations, but not non-exhaustive dimension few interpretations, even in cases where dimension few fits with the conversational goal the best. So for example, in 4, Alice says, we're looking for a campus value for the upcoming conference. We need to identify 3 options. Do you know where at campus one can hold a large conference? So here we have a typical Kant question that's embedded under the verb know, and the conversational goal is clearly mentioned 3. So here, despite the conversational goal being mentioned 3, the addressee Bob cannot felicitously reply with a denial while admitting that he knows one possible value. So he can say, yes, but I only know one such place. He wouldn't say, no, I only know one such place, or sorry, I only know one such place. And second, in discourse, unlike dimension 1 answers, dimension few answers are read exhaustively unless ignorance marked separately. So let's have a comprehension task based on the scenario described in 5. Alice has an electronic slicer, which comes with 10 blades. If you have never used electronic slicer, here is a picture. These blades have different colors and shapes designed for different ingredients. Now, while Alice is cooking, her friend Bob comes to help her cut carrots. Okay, so this is a scenario. Then Bob says, which blade can I use to cut carrots? If Alice says the green one, then more likely this answer will be understood non-exhaustively. She doesn't mean that the other blades cannot be used to cut carrots. However, if Alice provides 2 options, the green one or the black one, then more likely this answer will be read exhaustively. So she means that the other blades cannot be used to cut carrots. So there is a contrast in exhaustivity between dimension 1 answers and dimension few answers. In contrast to Kant questions, for questions with a partiality marker, such as, for example, there's no contrast in exhaustivity between dimension 1 answers and dimension few answers. For example, in 6, who is on your committee, for example. This question, to answer this question, no matter whether you mention 1 committee member as in A or 2 committee members as in B, both answers will be understood non-exhaustively. And furthermore, one can make an exact mention n inquiry by saying, give me n examples. So say like, give me 1 example, give me 3 examples, etc. So the contrast between can questions and the questions with a partiality marker with respect to the distribution of exhaustivity argues that the source of non-exhaustivity in these two types of questions are different. So next, I will propose a composition analysis of can questions and account for the mention 1 only constraint. Before I move to the actual composition analysis, I want to introduce a concept called answerhood. So answerhood is an operation to derive proper answers to a question based on the denotations of those questions. And this notion is important because many frameworks of question semantics nowadays encode question properties like truth, exhaustivity within the answerhood operators. The Fox 2013 proposes that a true answer is complete if and only if it isn't asymmetrical entailed by any of the true answers. And such answers are called maximally informative true answers. A definition is given in 7. The notion maximal informativity is weaker than exhaustivity. It derives either mention some or mention all, depending on the logical relation of the propositions in the answer space. So see how this works. Let's look at 2 answer spaces, Q1 and Q2. Both of them contain these 2 propositions, by A, by B. These 2 propositions are mutually independent, are true in world W. But difference is that Q2 also contains the conjunction of these 2 propositions. So therefore, Q1 is not closed under conjunction, Q2 is closed under conjunction. Then applying the answerhood operator in W to Q1 returns a non-sequence set containing 2 propositions, by A, by B. Both of them are maximally informative in the sense that there's nothing that asymmetrically entails it, but neither of them is exhaustive. So in this case, we would get a mention some rating in the sense that this question has multiple maximally informative true answers, and those answers are not exhaustive. In contrast, if we apply the answerhood operator to W in Q2, that would return a singleton set containing only the conjunction of the conjunctive proposition phi A and phi B. And this gives rise to a mention all rating in the sense that this question only has 1 maximum informative true answer, which is also an exhaustive true answer. So Fox answerhood predicts that mention some arises only if there is a world where Q has multiple maximum informative true answers and is unavailable if Q is closed under conjunction. Okay, so therefore later when we look at distribution of mention some, we're really going to see whether the answer space closed under conjunction or not. And if it's closed under conjunction, then mention some is not available. Okay, so now I'm going to move to the derivation of first order mention some interpretations. To see how exactly a question with a mention some interpretation is structured, I'm gonna look at some the linguistic properties of mention some answers. So previously I've already mentioned the mention 1 only constraint, and here we're gonna introduce 2 more, local exhaustivity and mutual independence. These properties are illustrated by the example in 9. The committee can be formed in 2 ways. It should either have the 2 members, Andy and Billy, or have 3 members, Andy, Billy, and Cindy. And the question is, who can serve on a committee? For this question, we can answer say Andy and Billy can, or say Andy and Billy and Cindy can, but we cannot just say Andy can. So there is a contrast between A and B, C. This contrast argues that mention some answers are subject to local exhaustivity. So for the question in 9, a mention some answer should specify all the members of a possible committee. In addition, the answer B, very interesting, is also a good mention some answer. So even though superficially, if we translate B and C as the formulas on the right, then answer C would asymmetrical entails B. So there needs to be something that help us to keep these 2 mention some answers mutually independent. So given these properties, I argue that in the structure of a question with the mission sum reading, there is an exhaustification operator O, which has a meaning similar to the exclusive particle only, that is applied to the local VP, and it's associated with the E-type W trace. So this O operator says the predicate is true, and any alternative that is not entailed by the predicate is false. So the structure of 9 is given in 11a. We have exhaustifier that is placed right below the possibility model. Then applying answerhood operator to W to the answer space returns a non-singleton set containing 2 maximally formative true answers. It's possible that only A and B serve on the common T. It's possible that only A and B and C serve on the common T. So this is a non-singleton set, so that's a mission sum interpretation. This analysis captures the linguistic properties of the mission sum answers. First, the local operator asserts local exhaustivity. So answer 9A is bad because it is false to say that it's possible to have only A serve on the common T. Moreover, the non-monotonicity of this operator makes individual answers mutually independent. So now we're translating these 2 sentences as 2 formulas on the right. Because the presence of the O operator, the 2 answers are mutually independent. C does not entail B. Okay, so this slide is about the first order mission sum interpretation. We say first order in the sense that the answers to the questions, are based on individuals, like atomic individuals or polarity individuals. And the next step is about higher order mission sum interpretations, higher order in the sense that the answers are derived based on generalized quantifiers. So I propose that the fronted W phrase finds a higher order trace pi, which takes scope between the possibility model can and the local exhaustifier. So the picture illustrates the answer space of this question. Imagine a scenario that only Andy and Billy can chair the committee, co-chairing is disallowed. In this picture, consider 3 types of answers: conjunctive answers, which are derived by Boolean conjunctions, individual answers, which are derived by multi-Boolean individuals, and disjunctive answers, which are derived by Boolean disjunctions. And here, on all these cases, disjunction, conjunction takes scope below the possibility model can, but above the local exhaustifier. The 3 answers in shade are the answers that are true in a given scenario, and the arrows indicate entailment relations among those propositions. Of here, the disjunctive answer at the bottom is entailed by the 2 individual answers. And in addition, the disjunctive answer is logically equivalent to the disjunction of the 2 individual answers. But let's see the predicted meanings of these 3 types of answers. The conjunctive answer is contradictory. So it's contradictory to say it's possible to have only A chair and simultaneously only B chair. The individual answers are independent from each other. And finally, the disjunctive answers are partial because whenever a disjunctive answer is true, there will be an individual answer is true and a symmetrical entails it. So this analysis explains the mission sum licensing effect of can with the presence of the modal verb can. The independent answers are not mutually exclusive. So imagine that we drop the possibility model can or replace the possibility model with the necessity model. The individual answers, we cannot have multiple individual answers to be simultaneously true while being exhaustified. In addition, this analysis also explains the mission 1 only constraint. So we have saying, so in reply to a can question with a mission sum reading, only the individual answers which each specify any one option are possibly maximally formative. In contrast, the conjunctive answers are always contradictory. The disjunctive answers are always partial. So if the addressee use a Boolean coordination to specify multiple options, they must be understanding the question with the mission all interpretation. And we're going to talk about mission all interpretation next. So recall we have 2 mission all interpretations because the mission all answer could either be convened as a conjunction or the disjunction, and each of them correspond to a different structure of the question. So here in the picture, this is just a copy from a previous slide. It's a logical form answer space for the mission sum reading. To derive the conjunctive mission R reading, all we need to do is to switch the scopal relation between can and higher order trace pi. So here I'm letting the higher order W trace pi to take scope above the existential modal verb can. With this change, the logical form becomes the one on the right. So you see here, conjunction, disjunction take scope above the possibility modal. And now the conjunctive answer isn't contradictory. Instead, it is logically equivalent to the conjunction of the two individual answers. And then the answer space is closed in the conjunction. The conjunctive answer is the only answer that is maximally informative true in this case. Okay. And the other case is that the other type of mission R reading is the case where the question accepts free choice disjunctive answers as mission all answers. A disjunctive answer to a can question is ambiguous. It can be either read with ignorance or with free choice. So in 15, who can chair the committee can say, we can say Andy or Billy can. And this answer could be either read with ignorance as in A, either Andy or Billy can chair, but I don't know who, or read with free choice as in B, say Andy can chair and Billy can chair. Okay. So given this ambiguity, I argue that in the can question, a disjunctive mission all interpretation arises only if felicitors' disjunctive answers can be understood as universal free choice statements. And following the tradition since Kratz and Shimayama 2010, I argued that universal free choice is derived by anti-exhaustification. The operator is defined in this block. I call it do, which is in reference to the Mandarin particle do because it just behaves so very similar to what this operator does. So it says the projection is true, well, for any anti-excludable alternative, the exhaustification is false. Before getting to the details of the computation, basically, when you apply do to a sentence like possible phi or psi, you return an inference that basically just says possible phi and possible psi. So it applies to a disjunction, return a conjunctive inference. And the same thing happens for the conjunction disjunction over two sentences with a possibility modal. So as I mentioned, the anti-exhaustification operator is called do in reference to the Mandarin particle do, which displays the properties of such operator overtly in questions and the declarative sentences. In 16, when you say do who can teach intro Chinese, with the presence of do, this question only have a mention already. In 17, John or Mary, do can teach intro Chinese. So here, do is associated with a pre-verbal disjunction, and it forces the sentence to have a free choice interpretation to mean both John and Mary can teach intro Chinese. So you see there is a very clear connection between the distribution of mission R rating and the distribution of free choice inference. So this slide provides a little bit more computation. I divide alternatives into two categories: innocent and excludable alternatives, which participate in exhaustification, and anti-excludable alternatives, which participate in anti-exhaustifications. Basically, alternatives are innocent and excludable means that they can be negated without causing any type of contradiction. What matters here is for the two disjunctive sentences with the possibility modal, their disjuncts are anti-excludable. So therefore, in the computation, in 18, applying do to the sentence Andy or Billy can chair the committee, it would give rise to inference with three components. Andy can chair or Billy can chair. It's not the case that only can chair. It's not the case that only Andy can chair. It's not the case that only B can chair. And the conjunction of three inferences is just equivalent to the conjunction of A can chair, B can chair. So this gives us a free choice inference. With this computation, with this derivation of free choice, we're ready to derive disjunctive mission R rating. So again, 19, this is just the logical form and the answer space for the mission sum rating. Then by applying the anti-exhaustification operator though within the questionnaire clears, and let it associated with the higher order trace path, and that gives us the disjunctive mission-all interpretation. So see now on the right hand of the slide, I'm adding the do operator pointwise to each of the prepositions. Nothing has changed about the conjunctive answer, but the disjunctive answer at the bottom is now logically equivalent to the conjunction of the two individual answers. So this answer now has a free choice interpretation. The answer space is closed under conjunction, so the question has a mission-all interpretation. And the maximum informative true answer is the answer that is convened as a disjunction. So interim summary, the mission one only constraint argues that distribution and license of mission sum isn't purely determined by pragmatics. The mission sum mission all ambiguity in Kant questions comes from minimal structural variations within the nucleus, and here I present two cases, two factors. One is the scope of relation between Kant and higher order depth trace, and second is the presence or absence of the anti-exhaustification operator. I had to skip a couple of issues like a distribution of mission sum in non-Kant questions, distribution of free choice disjunctive answers. Feel free to ask me about that in the Q&A. Right, so that's part one. Right, part two is on the dilemma between uniqueness and mission sum, and I will propose a new condition called relativized exhaustivity to resolve this dilemma. So let me just remind you what the dilemma is. Allowing complete answers to be non-exhaustive conflicts with Dayas' exhaustivity presupposition, which is important for explaining the uniqueness effects of singular which phrases. So to account for this, to resolve this dilemma, I'll argue for a new question interpretation condition called relativized exhaustivity. So roughly speaking, this condition has the effect of evaluating exhaustivity relative to the accessible worlds as opposed to the occurrence world. Let's see a little bit more data about uniqueness effects. Singular adaptation questions are subject to uniqueness. This example I've seen before. Which child came implies that only one of the children came. So to account for this effect, Dayas makes two assumptions. One is the exhaustivity presupposition, which says that a question is defined only if it has an exhaustive true answer, or say a true answer, which is the true answer that entails all the true answers. In addition, she proposes that a plural adaptation question has some best answers, while a singular adaptation question doesn't. So compare the two questions in 21. Assume that among children under consideration only and Billy came. The speaker knows that multiple children came, but she doesn't know who they are. In this case, she can facetiously ask which children came. And in the given scenario, there are three true answers. A came, B came, and B came. Here, the last one, A and B came, is the exhaustive true answer, which entails all the true answers. So Dayas' exhaustivity presupposition is satisfied. However, for the singular question, which child came, since which child only ranges over atomic individuals, this question only has two true answers. A came, B came. And none of the answer is an exhaustive true answer. So Dayas' exhaustivity presupposition is validated whenever this question has multiple true answers. Or in other words, this question is only felicitous when only one of the children came. So Dayas' work was focused on the first order readings of singular questions, but here also we want to see a little bit more about higher order adaptation quantification. So uniqueness effects also argue that singular adaptation questions cannot have answers formed out of Boolean conjunctions like A and B. So in 22, still the same question, which child came? If we were able to have Boolean conjunctions over the Montagu individuals A and B, then the question would have a maximum informative true answer formed out of A and B, but that's not the prediction of Dayas' presupposition. So instead, we're going to say that a singular that phrase shouldn't range over Boolean conjunctions. The disjunction conjunction symmetry is also seen in modalized singular questions. So say, which textbook can I use for this class? which textbook can I use for this class? Again, singular. We can say book A or book B. That sounds coherent. But book A and book B, that sounds pretty bad. So there is a contrast between disjunction and the conjunction when they are used to responding to a can question with a singular depth trace. So given this distribution, I argue that a singular which phrase may range over atomic individuals as well their Boolean disjunctions, but not their summations or Boolean conjunctions. Okay. So maybe now we're seeing the seems that a dilemma is just related to mention sum and uniqueness. What if we just don't care about uniqueness? Well, there will be a lot of undesirable consequences if we abandon Dayas presupposition, Dayas exhaustivity presupposition, and for the goals we care about here is that it was going to abandoning this presupposition will overgenerate mention sum ratings. And there will be three cases where there will be overgenerations of mention sum ratings, including questions with the uniqueness presupposition, questions with a non-distributed predicate, such as formed a team, and questions with an extension indefinite. So we're going to look at three cases one by one. 24, which child came? Imagine a scenario where both A and B came. In the first order rating, no matter whether we have a first order rating or a high order rating, the question would have two maximally informative true answers, including A came, B came. Yeah. So with Dayas exhaustivity presupposition, the question would be infinite terms because there's no exhaustive true answer, and that's a good prediction. Without Dayas exhaustivity presupposition, we would predict a mention sum rating instead of uniqueness effect, and that's clearly a bad prediction. And for 25. Which children form the team? Here, form the team is a non-distributive predicate. So again, this question can either take a first order rating or higher order rating. In the higher order rating, the answer space is closed under conjunction. We have four true answers. A and B form the team, C and B form the team, the disjunction of these two propositions and the conjunction of these two propositions. So the disjunction, conjunction are formed when we consider Boolean disjunctions and Boolean conjunctions. This answer space is closed under conjunction, so that's cool. However, we also have the first order interpretation, where we ignore the answers with disjunction and conjunction. It's just A and B formed one, B and B, C and D formed one. So this answer space in the first order rating is not closed under conjunction. Therefore, with Dayas exhaustivity presupposition, she would force the question to take a high order rating, and that predicts a mention all rating without uniqueness. However, without Dayas exhaustivity, we would predict ambiguity between mention sum and mention all, depending on whether the question takes a first order rating or a high order rating. And lastly, for questions with extension indefinite, they are predicted to behave the same as can questions in licensing mention sum, but that's again not the case. So the question, which movies did one of the boys watch in the individual reading is which movies why is such that one of the boys watch why. This question can have a mention all answer like Airman and Hulk, but not just Airman. So those will be overgenerating problems if we abandon Dayas exhaustivity presupposition. So here is the dilemma. Dayas exhaustivity presupposition explains uniqueness, but it is too strong to allow for mention sum. On the other hand, abandoning Dayas exhaustivity presupposition makes mention sum interpretations possible, but the assumed answerhood is just too weak to capture uniqueness, and it would overgenerate mention sum ratings for questions. Okay. Now let's put mention sum ratings aside, and it turns out that there is a challenging to Dayas exhaustivity presupposition independent from our interest on mention sum, and that is called local uniqueness. modalized singular double questions are subject to local uniqueness regardless of the modal flavor or the modal force. Hirsch and Schwartz 2020 observed that for singular questions with the possibility modal, you can clearly see local use of uniqueness. So in 27, which letter could we add to FO_M to form a word? We can say A or B. And the meaning of the answer is the unique letter that we add to FO_M could be A and could be R. And similarly, if we replace the priority modal code with epistemic modal code, the similar thing arises. Yeah, so this is independent from the modal flavor. In addition, in 2021 paper, I observed that for questions with the necessity modal, there's also such a symmetry. There's also such a local uniqueness effect in 29. Which chapter do we have to assign to the student? Which chapter do we have to assign to the student? This question implies that we're not allowed to assign more than one chapter. So the answer would be like chapter 1 or chapter 2, either is good. Dayas exhaustivity presupposition applies to the question answer space as a whole, so you cannot capture local uniqueness effects. And this problem is independent of mentioned sum. So now it seems that we have, in addition to our interest on mentioned sum readings, we have additional reasons to make some changes to Dayas exhaustivity presupposition to account for local uniqueness. Intuitively, uniqueness appears to be local if exhaustivity is evaluated relative to the accessible worlds as opposed to the occurrence world. So for questions in 30A, which chapter can we assign? Which chapter do we have to assign? In both cases, it gives rise to uniqueness effect like for every accessible world W prime. If we assign a chapter in W prime, then we assign only one chapter in W prime. So here we're really looking at accessible worlds. So to capture this idea analytically, in modal theoretic compositional semantics, this localness can be captured by changing the modal base. So the condition, I propose something called relativized exhaustivity. It says Dayas exhaustivity presupposition must be satisfied relative to every modal base that introduces a singleton set of accessible worlds, which verifies a true answer. So maybe the formula is a bit long. Let me just unpack this a little bit more. So here we have Dayas exhaustivity presupposition must be satisfied relative to every modal base M prime. So this is the modal base that introduces a singleton set of accessible worlds. Okay. And it verifies a true answer. So this part says it verifies the answer alpha, which is a true answer to Q, no matter whether Q is evaluated relative to M or the different modal base M prime. Okay. So this is the idea. Here, Q just refers to the set of true answers to the question. And the Dayas exhaustivity presupposition is just defined as the original form. Okay, so let's see the predictions of this analysis. Prediction 1, relativized exhaustivity permits mentioned sum readings. Question 33 is a typical mentioned sum question. And now let's just consider the first order mentioned sum reading. Who can chair the committee? Let's assume a multiple choice scenario. So there are two accessible worlds, W1, W2. The person who chairs the committee is A in W1 and is B in W2. Okay, so this is a multiple choice scenario. Then let's think about the answers of the question. With the original modal base M, this question has two true answers. It's possible that only A chairs. It's possible that only B chairs. This question doesn't have an exhaustive true answer. So it doesn't satisfy Dayas exhaustivity presupposition. However, we can also try to change the modal base into M1 or M2. M1 maps has only one maps W to the singleton set containing only W1. M2 maps W to the singleton set containing W2. So if the question is interpreted relative to M1, then the question has only one true answer. It's possible that only A tail. And this is going to be the exhaustive true answer in W to this question. And likewise, if the modal base is changed to M2, the question has only one true answer. It's possible that only B tier, which is also the exhaustive true answer to the question. So then, given the original modal base, relativized exhaustivity is satisfied in W. So it's a good prediction. Mission sum is permitted. You can see from this example, we can make a generalization of relativized exhaustivity to mission sum interpretations, which says that the mission sum interpretations of a can question of the form which A can P satisfies relativized exhaustivity if and only if the interpretations of the non-modalized version, which A P satisfies Dayas exhaustivity presupposition in every accessible world where it has a true answer. Prediction 2 is that this analysis avoids over predictions of mission sum. In 34, for questions with for WH questions with a non-distributed predicate, previously we saw that without Dayas exhaustivity presupposition, we would predict and mission sum mission ambiguity. But here, in the multiple team scenario, the first order interpretation of 34 would violate relativized exhaustivity, just like they violate Dayas exhaustivity presupposition, because there's no modal. If there's no modal, then there's no difference between Dayas exhaustivity presupposition and relativized exhaustivity. For questions with indefinite, like 35, which movies did one of the boys watch? Also, again, that wouldn't be any different from the exhaustivity presupposition. Relativized exhaustivity makes exhaustivity be evaluated relative to smaller modal base, not relative to a smaller discourse domain. So therefore, for any non-modalized questions, including questions with indefinite, relativized exhaustivity makes the same prediction as Dayas exhaustivity presupposition. Now I'm going to look at predictions regarding uniqueness. For non-modalized question, the selection of modal base doesn't affect non-modalized questions, and therefore relativized exhaustivity carries forward the merits of Dayas exhaustivity presupposition in explaining their uniqueness effects, and nothing changed. For modalized questions, things will be more interesting, and here we have just focus on local uniqueness for this presentation. 37, which chapter do we have to assign? It presupposes that we shouldn't assign more than one chapter. Which chapter can we assign presupposes that we can assign one chapter but not more. So in both cases, there's sort of like universal local uniqueness. Then let's look at the question with the necessity model. 39, question is, which chapter do we have to assign? Implies that we shouldn't assign more than one chapter. One can reply this answer by saying chapter A, chapter 1 or chapter 2, either is good. Here we have disjunction being interpreted under the necessity model. So to show how relativized exhaustivity captures the local uniqueness effect, let's assume a scenario that violates local uniqueness. Okay? Assume that we have the modal base matches, the modal base maps the accessible world W. The modal base maps the terms world W to 3 accessible worlds, W1, W2, W3. In W1, we assign only chapter 1. In W2, we assign only chapter 2. And in W3, we assign both chapters. So this is the world that violates uniqueness. Then the question, interpreting this question, given the original modal base, returns a set containing only one true answer. So it's possible that we assign chapter 1 or chapter 2. Okay? So this question, the question has exhaustive true answer in W. So Dayas exhaustivity presupposition is satisfied. It cannot explain why this question would be bad when local uniqueness is violated. However, let's look at the prediction for relativized exhaustivity. So here the true answer is possible. We must assign chapter 1 or chapter 2. This can be verified by the singleton set of the worlds containing W3. So therefore, by relativized exhaustivity, this question should have one exhaustive true answer in W when interpreted relative to M prime, which maps W to the singleton set W3. Now check the consequence. Given M prime, the question has 3 true answers. Yeah, just look. It had 3 true answers. We must assign chapter 1. We must assign chapter 2, and we must assign either chapter 1 or chapter 2. Okay. So in this case, the question doesn't have an exhaustive true answer. So given M prime, the question has no exhaustive true answer in W. Therefore, when local uniqueness is violated, relativized exhaustivity is violated. So that is a good prediction. This contrast in the prediction between Dayas' exhaustivity presupposition and the relativized exhaustivity also shows that relativized exhaustivity is a mandatory condition for question interpretation. If it were optional, or if it only came into play in cases where Dayas' exhaustivity presuppositions are violated, we would expect local uniqueness to be optional or absent in singular box questions. Now let's think about uniqueness in canon questions. So according to the translations we had before, sentence 41b with the can satisfies relativized exhaustivity if and only if the non-modalized counterpart in 41a has a unique true answer in every accessible world where we assign any chapters. So again, let's assume the same local uniqueness violating scenario. Again, we have 3 accessible worlds, W1, W2, W3. We assign only chapter 1 in W1, we assign only chapter 2 in W2, and we assign both chapters in W3. So in W3, again, is the world where local uniqueness is violated. When the question is interpreted with original model base, it has 2 true answers. We can assign chapter 1, we can assign chapter 2, and then exhaustive true answer doesn't exist. Recall, since the true answer we can assign chapter 1 can be verified by the world W3. Therefore, relativized exhaustivity is satisfied only if the question has an exhaustive true answer when it is interpreted relative to M prime, which maps W to the singleton set containing only W3. So let's see whether that's the case. With the model-based M prime, the question has still these 2 true answers. We can assign chapter 1, we can assign chapter 2, and exhaustive true answer still doesn't exist. So when local uniqueness is violated, relativized exhaustivity is also violated. So here comes the conclusion. I observed that mission sum answers are subject to a mission 1 only constraint, which cannot be explained by pragmatics. I argued that mission sum, mission all answers are derived as complete answers by single answer with operations. The mission sum and the mission all ambiguity in can questions come from minimal structural variations within the question nucleus. And then I show you that there's a dilemma between uniqueness and mission sum. Allowing non-exhaustive answers to be complete would cause a troubling conflict with Dayas' exhaustivity presupposition. And this condition is crucial in accounting for the uniqueness effects in questions. And finally, I present a solution to this dilemma, says that question interpretation can violate Dayas' exhaustivity presupposition, but mandatorily presuppose relativized exhaustivity. This condition permits mission sum whenever that's needed without overgenerating it, and moreover explains the local uniqueness effects in modalized singular W questions. So that is the presentation. Thank you for your attention.
Okay, thank you very much for a very nice talk. Let's go to questions. We have questions. Questions. I have one myself, but I want to. Mui Yang.
Yeah. Can you hear me?
Yes.
Okay. Thanks for the talk. For now, I just have a clarification question about your notion of model base that you used in the paper.
Mhm.
So I assume that you have something close to Kretzer's notion of model base in mind. So it's something provided by the context with reference to like a set of rules, a set of what's optimal for us to do or something like that. So I was wondering, because in your crucial notion of relativized exhaustivity, you're quantifying over a set of model bases, which isn't usually what Kretzer would do in her framework. So I was wondering, what is your criteria for a context to determine what kind of model bases there are?
Yeah, so that's a very nice question. Thank you. Just change the. So basically, I think you are pointing to the definition for relativized exhaustivity, which does need to make a reference to the model base, because this is really about all the model bases that can be generated by substituting, looking for the singleton sets of successful words and verify the true answer. And so first, I don't really say that is like I'm not sure whether that's the thing that you're having in mind, but I'm not really assuming alternatives for model bases. But I think the question that you might be curious is to hear is that how can I just extract the model base and then making substitutions over it, right? Yeah, this is actually one of the things that's been pointed out by the reviewer, and especially I think it's a very crucial issue when we think about modal verbs that are embedded, because it's going to be so hard to extract this and then making changes to that. So this is something that I didn't talk in this didn't present in the talk, but also there was one version paper that I discussed about this, is that I treat the modal expressions as like functions from modal bases to so modalized sentences as functions from modal bases to propositions. So basically you can, and then modal bases will be just the arguments of the sentences. Then you can always easily extract the modal base. And then that will not be treated as in a sense like a free variable, but more something similar to probably variable-free semantics. Then you can always just take some modal base and plug it in as a variable, as argument of that sentence. Then that will be very easy to make changes to that. So that would require some a bit more changes to the framework, because now I'm defining sentences as functions from modal bases to propositions, not just propositions. But I think still, in principle, that should still work.
Thank you.
I have a follow-up since we're on this. I didn't understand why the modal base had to be restricted to things that introduce singleton sets of accessible worlds. Couldn't you not have things that agree on the answer?
Yeah, so in the first version that I was trying to work on, didn't restrict it to singleton sets of possible worlds. Instead I said like the minimal sets of possible worlds that verifies the answers. But then just because it seems that those that are not singleton set don't really affect the predictions. And for the sake of presentation, I just use singleton sets because that captures intuition that we are evaluating exhaustivity relative to the accessible worlds. So basically, I'm extracting singleton sets so that each time I'm moving to one single accessible worlds. So that's just to capture that intuition. If we change that into something like the minimal set of accessible worlds, that the prediction wouldn't be any different. That's just a little bit more difficult to present.
Okay, good, thank you.
Thank you.
Other questions? I had also a data issue. I did not get the which or who can serve on the committee one. Where is that? That's there, number 9, right on page 9.
Yes.
So we have a committee that has to have either 2 or 3 members.
Right.
And ask who can serve on the committee. I didn't understand why Andy Can was bad. Is that actually taken to be bad? I mean, so if the question were who can form the committee, then clearly Andy Can would be bad, but that's because form requires a plural. But my intuition was that this was a perfectly fine thing to say. So I was wondering where this intuition comes from exactly.
The original judgment comes from Danny Fox, but it was like a long time ago. So the point here is that the answer itself is still true, but it's just when we try to. So, for example, let's make a comparison, like who is invited to this conference? Who is invited to this conference? Then we can say Yimei is. That's still a good answer, but cannot be used as a complete true answer to the question. Still feel that something hasn't been said. So we wouldn't just use following tone. We say Yimei is, and then to indicate that someone else is also invited. So this is the similar case here. Can serve on the committee. If just say Andy can, it's a bit odd in the sense that we do want to specify. Seems that we want to also specify the other members that the other members in the committee. So the answer is still a true answer, but it's just not a complete true answer. Then some kind of prosody or ignorance mark will be required to make the sentence good.
Okay, so I guess what I was doing implicitly. I read it with a continuation intonation. So who can serve on the committee? Well, Andy can, and you kind of imply that more to it than that. And if you say Andy can, that implies a finality and completeness that is not warranted, right? But exactly. But then is the intuition that you get the complete kind of final fall intonation to be okay for B and C?
Yeah, that is the claim. So for mention some answers here, I have this little backslash to indicate the intonation of the answers to show that we don't have the rise. And the intuition is really that for B and C, as long as they specify the full composition, then a falling tone is okay.
I see. Okay. Thank you.
Thank you.
Okay, other questions? Yes. Joe.
Hi, is my mic working? Yeah, okay. I have a simple question. Well, it might be simple, it might not be. So you're addressing can questions, but it seems like the existential operator is the important aspect. So what about might questions? It seems like the same thing would apply, but you have thoroughly not included any might examples. And so I was wondering if there was some reason to exclude might from your analysis.
Yeah, this is a very good point. So as you pointed out, the current analysis on the distribution of mentioned sum, it's only making reference of the quantificational force of can, and it says nothing about the modal flavor. So it wouldn't make any difference between epistemic modal and goal-oriented model. So that's exactly the case. That's a very fair question. So my reply. So basically, let's see questions with epistemic model. It doesn't have the behavior like mentioned some the same as questions with goal-oriented model. So that would be, if we just look at the assumptions I have here, that would overgenerate mention some gradients for those questions. So my reply to this question is like, we actually the modal flavor matters for pragmatic considerations, and that is just not unique. It's not just unique to epistemic models. It also applies to other models like, for example, deontic models. So like where can I something like where can I who can sign my who can give me well I cannot have a good example in my head, but the deontic models don't license mention sum either. So I think the problem is related to pragmatics. When we say mention, for example, say where might John be, where might John who might be in the room, something like that, who might be in the room, then the goal of the question isn't really about to know the people who might be in the room, but it's really to know who is in the room. So just answering, so it's trying to identify the individuals who is actually in the room. So therefore, we just have a mention sum answer that wouldn't be sufficient. And then for other like deontic models, say that would also be different. So for example, like I'm just trying to come up with a deontic model. Like who can let's see.
Who may leave?
Something like yes, something like who can I ask to sign this document? This who can I sign? Who can I ask to sign this document and to understand the deontic model? Then the intuition is that you want to make sure the law applies no matter where the agent is. So you want to, in this case, you would have to be exhaustive. So basically, the short answer to your question is that in terms of the prediction of the theory itself, it doesn't rule out the possibility of letting those questions to have a mention sum rating. However, for pragmatic considerations, those questions do need mention all rating for separate reasons.
I see. I actually get a lot of mention some interpretation for with might.
Oh, really? So I'm probably yeah.
Like if you replace can in many of your questions, I think you the same predictions.
Yeah, there are cases like that. So let me just plug in one case. Here I have one. I need help. Who might be in the office at this time? This one. I need help. Who might be in the office this time? So here we have a possibility model might, and this comes from Dial. And my explanation is, in this case, I don't really want to say that it's the might that licenses mention sum, because we also have case that might doesn't license mention sum. And for that reason, I'm just assuming that in this case, the context could provide some restriction that contains can. So the question will paraphrase like, who might be in the office at this time such that they can help me. So then there will be a covert restrictor that provides a nuclear, the covert restrictor to the question that turns this question from a non-can question to a can question. And that's how the mention sum is licensed.
Okay. Thank you.
Thank you.
Okay, Nordi, you go next. I'm sorry, Nordi, I can't hear you. You have to turn your mic on.
Sorry, can you hear me? Can you hear me now?
Thank you. Yeah.
I have a question about the formulation of the relativized exhaustivity. In some so I'm just wondering to which place you would allocate the ordering source of the relevant model.
Yeah. So
Yeah.
yeah. The ordering source I didn't include here because ordering source is the part that is something that we use to identify the best words. Here is not that relevant, but in some cases becomes relevant when we think about probably like conditional mission sum. So things like where can I send out a package? Where can I send out the package? And some people might say UPS or USPS. UPS is one that you can usually use to deliver express, and USPS is something that is cheaper. So then there will be covert ordering source that's relevant to your preference about whether you're going to deliver something faster or something cheaper, and that will be relevant to restrict the modal base. For those cases, for the case I have here, the ordering source are not so relevant, so therefore I just ignore them. But for formulating those conditional mission sum, you're gonna restrict. We need to restrict the mission sum. We're gonna restrict and order the. It's like if you want to deliver something fast, then you blah blah blah. If you want to deliver something cheaper, then blah blah blah. So that will be relevant for the interpretation.
Yeah. So. Okay. Thank you.
Yeah. So here we just assume that ordering source is the same and nothing changes.
So my question is, if it changes, how do you reflect this change in your formula? So might be M prime or some other.
So my understanding is that because here what matters is just to find a singleton set of accessible worlds. And then in Kratzer system, the set of accessible worlds determined by the modal base and ordering source together. And then if I just here I'm just tuning one parameter and keep the other parameter the same, then it wouldn't change. I see no reason of changing the ordering source because in terms of, so like, for example, can questions. So where can I get coffee? My preference would be the same thing. Would be, I always just want to get something cheaper. I always want to just get something that's from somewhere that's closer. Then there would be no motivation of changing the ordering source in this definition.
Okay, got it. Thank you.
Thank you.
I am going to follow up on that because I'm a little bit confused here. So if you, I mean, an ordering source orders the results of the world in a modal base, right?
Yes.
And so if the modal base only gives you a unique thing, then it can't be ordered. So what you're saying is that it really M prime should be thought of as the result of the ordering imposed upon a modal base in the cases where the ordering matters. Is that, do I have you right on that?
So first, to make sure that all the mission sum answers are equally good, we do want to say that the worlds that verify these answers are equally good. So like where can we get coffee? We would comparing places that pretty much comparable, Starbucks and Pete's, assuming they have similar coffee, similar closer. But if one is too far, one is too expensive, then very unlikely that people, then more likely people wouldn't take that as the compare option. And that's also especially so therefore I always look at two options that are equally good. So therefore for ordering source, even I would imagine that so for example, like in the same example, where can we get coffee? Then W1 is that you go to Starbucks, W2 is that you go to Pete's. Then these two worlds should be equally good with our ordering source. So so here I'm still applying the same ordering source. It's just when I restrict the modal base, I ignore some other possible worlds, but the way that I order those worlds is still the same.
I'm still wondering, how do you order a single world? If your modal base gives you a single world, how does it get ordered?
Oh, so I'm not entirely sure if that is a problem. So in terms of ordering sort, we just, because basically my understanding is that M and O together determines the best worlds. Maybe just the formalizations kind of making the set of worlds too little, and then we don't apply, the ordering wouldn't affect anymore. But or another way to put this maybe is that to satisfy people who want to add ordering source is that I would just change M prime into as a dual, including M prime plus the ordering source, but keep the ordering source the same. So then M prime itself could be adding more possible worlds, but then in terms of the ordering source, then we'll still have just one best world.
Yes. Okay. That was what I
Yeah.
thought. And what do you look like you had a follow-up?
Yeah, I just wanted to add that the M prime in 31 is the best words with for which in which both model base and ordering source are both taken into consideration. And that yeah, I just wanted to add that
Yes.
point here.
Thank you.
Okay, other questions? Anybody, other questions? Okay, then I think what we'll do is we'll stop here. Thank you very much, Yimei.
Thank you. Thank you all.